Now we will consider the chapter on oscillations. We will discuss the concepts that we need to know to do this chapter on oscillations. Number one, we need to understand that and use the terms like displacement represented by x, amplitude is xo, period is capital T, frequency is f, angular frequency or angular velocity represented by omega, phase difference in the context of oscillations. Number two, we need to understand the simple harmonic motion represented by SHM. Motion occurs when the acceleration is proportional to the displacement from a fixed point and x in the opposite direction. Number three, analyze and interpret graphical representation of displacement, velocity, and acceleration for simple harmonic motion. In other words, you need to be familiar with the displacement time graph or xt graph, velocity time graph or vt graph, and acceleration time graph or at graph. Number four, you need to be able to describe the interchange between kinetic and potential energy during simple harmonic motion. Number five, understand that the resistive force acting on the oscillating system causes damping. Number six, be able to sketch the displacement time graph for damping and be aware of the exponential nature of damping. Number seven, understand and use the terms light, critical, and heavy damping and the associated displacement time graph or xt graph. And finally, 8, understand the meaning of resonance, and that resonance involves the maximum amplitude of oscillations. These are the formulae that you need to know in this chapter. But before we understand what the formula means, we need to understand what the symbols represent. X represents the displacement. XO represents the maximum displacement or the amplitude. Omega represents the angular velocity. T represents your time. And this capital T represents the period. F represents frequency. And V represents velocity. The first formula you need to know is X equals to XO sine omega T. The second this formula allows you to find the displacement at different time. The formula number 2 is omega equals to 2 pi f or omega equals to 2 pi over t. You need to understand that if you know your t, you can find your f. And once you know your t and f, you can find omega, which is either 2 pi f or 2 pi over t. Similarly, if you know omega, you can find your f and your t. This calculation is very important in the examination. Then number 3 is V equals to XO omega cos omega t. This formula allows you to find the velocity at different times. Number 4, V is maximum when cos omega t equals to 1. Therefore, your V max equals to XO times omega. Number 5, V equals to omega XO squared minus x squared. This formula number 5 allows you to find the velocity at different displacement. Number 6, A equals to minus omega squared XO sine omega t. But if you combine number 6 and number 1, you find that your acceleration equals to minus omega squared x. This formula here. This is where you get the definition for simple harmonic motion. You notice that your A is proportional to your displacement. And your minus sign here shows that your A and X are measured opposite directions. Number 7, A is maximum when sine omega t equals to 1. Therefore, your A maximum equals to minus omega squared XO. And finally, number 8, the maximum energy for the system is equal to the maximum kinetic energy, which is equals to half m omega squared XO squared. And these are the partial examination questions that came out in the exam from February, March 2022 to May, June 2023. Altogether, there are 7 questions. A lot of questions in this chapter involve graphs. Therefore, you must be able to interpret the graphs. Information that can be obtained from the displacement time graph. Displacement time graph look like this. From the displacement time graph, we can get the maximum displacement XO. We also can get a period T from the graph, as you can see in the graph. From T, we can calculate the frequency and angular velocity, omega, because omega equals to 2 pi f or omega equals to 2 pi over t. The second graph you need to understand is the velocity time graph. From this graph, you can get the maximum velocity, and combining the maximum velocity and your maximum displacement or amplitude, we can calculate your T and F. This is because your Vmax equals to XO, which is amplitude times your omega. The second information you can get from this graph is the period T, and we can then calculate F and omega. The third graph is acceleration time graph, which looks like this. From this graph, you can get the maximum acceleration. Combining the maximum acceleration and the amplitude from the first graph, you can calculate your omega, and from omega, you can calculate your T and F. This is number one. Then number two, we can also get the period from the graph. From the period, we can then calculate your F and your T. The next graph you need to know is the velocity displacement graph, which is this one. From this graph, you can get the maximum velocity from here, and also the amplitude from here. You can then combine your Vmax and your X amplitude to calculate your omega, T, and F. Then we have to know the acceleration displacement graph. This graph consists of a straight line with a negative gradient passing through the origin, which is here. The gradient of the line is minus omega squared, which means if you can find the gradient, you can find omega. The next thing you can find is the amplitude of the oscillation. You can then combine omega and XO to calculate the Vmax, F, and T. Because the formula for Vmax is this, and the formula for Emax is this. The next graph is energy displacement graph. From this graph, you can get the maximum kinetic energy, which is here, and also the amplitude XO, which is here. We know that the formula for maximum kinetic energy is half m omega squared XO squared. You can then sketch the potential energy curve and use the maximum kinetic energy and XO to calculate omega, F, and T. The final graph that you need to know is amplitude frequency graph. This is for resonance. At resonance, the amplitude is maximum. So you look for the maximum amplitude, and then this is the resonance frequency, or the travel frequency, or the natural frequency of the vibrating object, FO.